Okay, we're going to finish working on the on your own question. So as a reminder, the question was to graph 6x plus y equals 12, and then tell the slope. Oh, we already did that part of it. Okay, so we still need to graph this. So I'm going to graph it with slope-intercept form. So go ahead and grab some graph paper. I know it needs to hit 12 on the y-axis. And then it needs to have a slope of -6. So go ahead and take a minute, get your graph paper. If you want to, when I do the graph, I'm going to have my y-axis go by 2's. So you can change it and go by 2's if you want. You can go by 1's. If you go by 1's, your graph is just going to be really tall. Okay, grab some graph paper and graph that equation. For my graph, I decided to take my y-axis and have the intervals go by 2's. I had my my x-axis still go by 1's. So they don't have to go by the same amount. But whatever you have your interval set at, you have to do that set for the whole axes. So for instance, like, don't do this, but let's say you had this. You can't say, so we always start at 0. You can't be like, I'm going to leave some space. 1, 2, 3, 4. You cannot do this. So if you leave a space, because technically this is a half, right? You can't go 0, half, 1, 2. You could go 0, half, 1, make this 1.5, make this 2. That'll be 2.5. This would be 3. So whatever you do your intervals for, you have to do it for the entire time. You can't just randomly skip something because you're trying to space things out. So it's okay to do spaces. You just have to do it the entire time. Okay, so for this, my y-intercept is 12. I'm going to put a dot at 12 on the y-axis. It has a slope of -6. So that's down 6 over 1, down 6 over 1. So on the y-axis, you're going down 6. On the x-axis, you're going +1. If you change your intervals, though, you have to be careful. So if I'm going down a box, I'm actually going down 2 units. So I'm going down 2, 4, 6 over 1. 2, 4, 6 over 1. 2, 4, 6 over 1. Once you have a few, go ahead and connect it with a straight edge. And then make sure you have arrows on both sides. And that is the graph for 6x plus y equals 12. Okay, go ahead, cut that out and glue it into your notes if you haven't. For example 2, it's going to give us word problems. It asks us to graph the function and give the domain and range. Remember when we're doing domain, domain is your x values, range is your y values. We're dealing with word problems though, so you have to think about what's going to make sense for the word problem. So for example 2a, I'm going to read the word problem to you and then we'll just write down the important information. Sal opens a new video store and pays the film studios $2 for each DVD he buys from them. The amount Sal pays is given by f of x equals 2x, where x is the number of DVDs purchased. So important information. He pays $2 per DVD. It also gave me the equation, which is f of x equals 2x. And then it also told me that x is going to stand for the number of DVDs. Okay, so first looking at the equation that they gave us. We all recognize that this is function notation. We learned this in the last module. Function notation is just a fancier way of writing y equals. So f of x is just a fancy way of writing a y. So it's really y equals 2x. Okay, we're going to first start by setting up a table and use numbers for the x's that make sense. So x is the number of DVDs. That's your independent variable. Y is going to be how much they cost. That's your dependent. The cost depends on how many DVDs you buy. Okay, can I buy negative DVDs? Because when we make a table, we have to come up with X values. So buying negative DVDs, does that make sense? No, that doesn't make sense. We can buy 0 DVDs. How much do 0 DVDs cost? $0. So if you just plug in 0, 2 times 0 is 0. Can I buy half of a DVD? That doesn't make sense. So we're just going to use whole numbers. So when you get your X's, you pick them. It's just when it's a word problem, you need to pick numbers that make sense for the situation. Okay, if I buy 1 DVD, or if he uses 1 DVD, he has to pay $2. If he buys 2, what does he pay? Bueller. 2 times 2 is, thank you, wake up. Okay, if he buys 3 DVDs, how much is he going to spend? $6. And then this goes on forever, right? He can buy 10, he can buy 20, he can buy 100, he can buy 1,000. Okay, we're going to graph this because the directions say graph and give the domain and range. So grab some graph paper. If you look at your X values, there's no negatives listed. So we don't need to use all quadrants. We can use just quadrant 1. So I don't need to put all the other 3 quadrants because I'm not going to have negative numbers. That doesn't make any sense. Okay, for the x-axis, the x is going to be the number of DVDs. So I'm going to start, you always start with 0. I'm just going to go 1, 2, 3, 4, goes on forever. The y-axis is going to be the cost. I'm going to go by 1. Yeah, I'm going to go by 1s there too. 0, 1, 2. You can go by 2s if you wanted to. You can go by whatever. Okay, if I bought 0 DVDs, it cost $0. So put a dot at 0, 0. If I buy 1 DVD, it's going to cost $2. If I buy 2 DVDs, it's going to be $4. 3 goes to 6. If you have space, and I have space for my 4, 8. Okay, can I buy half a DVD? So do I want a dot at, oops, next line. Can I have half a DVD? No, that doesn't make sense. So do not connect the dots, because you're not going to include all of the little points in between. What kind of graph is this called? This is a discrete graph because we don't connect the dots. Okay, cut that out, glue that into your notes, and then we have to do domain and range. Oh, stick in the basket for me. Thank you. Okay, domain. It's asking for the x values that make sense for this situation. Range is the y values that make sense. So in this situation, I'm going to be using my x values that made sense. So I didn't use negatives. I used 0, 1, 2, 3. So I can start listing them. Dot, 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 goes on forever. And you can add in there, it is, how did I write that? All whole numbers. Because he can buy 10 DVDs, he can buy 100. So domain is what x values make sense for the situation. Range is what y values make sense for the situation. So it started at 0, 2, 4, 6, going on forever. And this was all even whole numbers. So the range was all even whole numbers, 0, 2, 4, 6, 8, going on forever. And that's all we have to do that for that. So it asks you to graph it and then state the domain and range. And then we talked about this is a discrete graph because we don't connect the dots. Okay, we're going to do another one like that. Anyone still need this up? Okay. 2B. For example, 2B, the word problem is, Elsa rents a booth in her grandfather's mall to open an ice cream stand. She pays $1 to her grandfather for each hour of operation. The amount Elsa pays each hour is given by f of x equals x, where x is the number of hours her booth is open. Okay, so the important information I'm going to write down is she's going to pay $1 for every hour that she's open. And then it gave me the equation of f of x equals x. And it said that x stands for the number of hours. Okay, I'm going to rewrite the function notation equation. So this is just a fancy way of writing y equals x. F of x is the same as y. Okay, we're going to make a table first. X stands for the hours. That's your independent variable. Y is going to stand for how much money she has to pay. That's your dependent. So she pays, whatever she pays depends on how many hours she is open. Okay, can she be open negative hours? That doesn't make sense. So we're going to start with 0. If she's open for 0 hours, she pays $0. Your equation is y equals x. So whatever you plug in for x, y is going to be the same number. Can she be open for part of an hour? Yeah, she can be open for half an hour or a quarter of an hour. So when we graph this, we will connect the dots. For 1 hour, she's going to pay $1. 2 hours, she'll pay $2. 3 hours, $3, and so forth and so on. Okay, now we're going to graph that. I'm only using whole numbers, so I don't need to go into my negatives. So when I go to graph it, I'm just going to use quadrant 1. So x stands for the hours. So we have 0 hours, 1, 2, 3, 4. My y-axis is how much she's going to pay. I'm going to have that go by 1s as well. So if she works for 0 hours, or if she's open for 0 hours, she pays $0. If she's open for 1 hour, it's $1. 2 hours, $2, and so forth and so on. And we talked about, can I be open for half an hour? Yes. So we're going to connect the dots. So use your straight edge. Okay, when you connect your dots, it's going to stop at 0, 0. It's not going to continue down here, so don't put an arrow down here because that says the line keeps going, and it doesn't go negative. It stops at 0, 0. The line can keep going on forever the other direction, so it does need an arrow on that side. Okay, go ahead and cut that out, glue that into your notes. Next, we have to state what's the domain and the range. Okay, domain is your x values. So what x values we used, 0, 1, 2, 3. However, it does include all those numbers in between, all the decimals, all the fractions in between. So the way I can write this is x can be anything that's greater than or equal to 0. That way I can say, yeah, it can be a half an hour, it can be a quarter of an hour. Range is your y values. Our range was anything bigger than 0, which also includes all the decimals and all the fractions in between. So the y value is going to be greater than or equal to 0. Okay, now you're going to do one on your own. I'm going to read it to you. Christoph rents a kiosk in the mall to open an umbrella stand. He pays $6 to the mall owner for each umbrella he sells. The amount Christoph pays is given by f of x equals 6x, where x is the number of umbrellas sold. Graph the function and give its domain and range. Okay, so important things to write down. He's paying $6 per umbrella. I would write that down. I would write down the equation, which is f of x equals 6x. f of x equals 6x. And then also x stands for the number of umbrellas. So first, go ahead and make a table and think about what values of x will make sense for the situation. X is the number of umbrellas sold. He pays $6 to the mall owner for each umbrella that he sells. After you make your table, then you're going to graph it, state the domain and range. I'm going to zoom in on the graph that they have on the packet. You don't have to go by 6s, or actually this is going by 3s. You can go by 1s if you want. If you want to do a graph by 2s, this is the graph that they used. Okay, go ahead and finish this. Graph the equation and state the domain and range. Okay, when I made my table, I used 0, 1, 2, 3. The equation is y equals 6x. When you graphed it, you do not connect the dots because you can't buy part of an umbrella. So you should have a dot at 0, 0, 1, 6, 2, 12. If you went up to 318, 424, it just depends on how high you made your y-axis go up by. The domain, 0, 1, 2, 3, it's only whole numbers because you can't buy part of an umbrella. And the range was 0, 6, 12, 18, so forth and so on, which was your multiples of 6. And then hopefully you noticed you don't connect the dots because you can't buy part of an umbrella. So that is a discrete graph. Okay, make sure your notes are nice and neat. You can read them. You are going to finish today by doing the exit ticket in class. You have to finish it before you leave, though. You're not allowed to leave my class until it's finished. It is on paper. You can work with friends, and I'll have the answer key up here at my desk.